So our next unit goes with imaginary numbers, and we come and we talk about a complex number. A complex number is the highest type of number we have. It has two parts. It has a real part and it has an imaginary part. And we write it in this form, A plus BI. So we're saying we have this many real parts and this many imaginary parts. We'll go into that a little more tomorrow, but right now we just want to learn that once again, remember when we start working with complex numbers that they have to be able to do all the math that's already been invented. So they have to be able to do the basics: add, subtract, multiply, and divide. Of course, they have to do much more than that, but that's all we're requiring you to learn about. So adding is very simple. Just like you can only add like things, for example, if I gave you x plus 3y plus 2x minus y, you could only put the x's together and the y's together. Likewise, when you're adding, subtracting, you can only do like terms. So in this case, the real part of this first number is -2, and the real part of this second complex number is +6. That will get you our A, which is 4. Now, if we were to do our imaginary part is 7i in the first complex number and 2i in the second complex number. So B is 9i. Now, obviously, when you go to do this, you don't need to write this all out as such. I'm just showing you how we add together the real part, how we add together the imaginary part, and we get our new complex number, 4 plus 9i. And again, for those of you in physics, this kind of looks familiar. It's kind of like adding vectors together. All right, so it's really simple. All right, if I was going to subtract here, 5 minus 2 tells me my A part is 3. Careful, 3i minus -7i would get me a B part of 10i. And once again, you can always just do distributive property to make your life easier. I could have up here, and generally that's what I usually do, is I distribute the negative, so that's going to become add the opposite, and so then you're just adding. Multiplying, well, that's another thing. Once again, I multiply by putting my numbers just like I was multiplying back in 3rd grade. So 2i and 5i, remember, is 10, wait for it, I squared. 2i times 3i is 6i. Now 7 times 5 is 35i, and 7 times 3 is 21, and when I add them together, I get 21 plus 41i plus 10i squared. But wait for it, we remember that I squared is really a -1. So this really turns into -10. And when I go to clean everything up, now I have a real part of 21 minus 10. So I have a real part of 11 and an imaginary part of 41. Division. Our word, the conjugate, is coming back. So let's review for a second the conjugate. We just did it in factoring. So if we did a minus b and we multiplied by a plus b, we called these conjugates of each other because they made the middles drop out. We knew that we would have gotten a squared plus ab minus b squared. So we know these middles drop out, and we're left with a squared minus b squared. That is a very important thing to remember if you'd like to be able to divide quickly. So where would we use the conjugate? On the bottom. If I took the bottom, and remember the conjugate just changed the middle sign. So this is negative 3 minus I. And what we do to the bottom, we have to do to the top. Hopefully you got into that in 7th or 8th grade math, where this means you're not really changing the weight of the problem because you're multiplying by a 1. If we do the bottom, negative 3 times negative 3 is positive 9. Negative 3 times negative I is positive 3i. Positive I times negative 3 is negative 3i. I times negative I is negative I squared. Now you can see why the conjugate is so important. Why do I want to do all that? I need to recognize I'm multiplying by conjugates here. And I can save a lot of steps if I just understand I'm multiplying by conjugates. I need to understand there won't be any middle terms. So negative 3 times negative 3 is 9. I know now it's going to be a minus in the middle. I times I is I squared. That's the quickness that we want you to be able to recognize. Moving on with this, we know that I squared is that negative 1 again. So this is really 9 minus a negative 1, which means the bottom ended up being the number 10. And you know that you cannot divide by a radical, correct? Back in Algebra 1, if we take another side step, back in Algebra 1, hopefully you were told that you cannot have this, that you had to rationalize the denominator. And why did you have to rationalize the denominator? Because denominators cannot contain square roots. So you'd multiply top and bottom by radical 2 over radical 2. Once again, really multiplying by the number 1, and you get 3 radical 2 over 2. Now basically why we do that is because it's a lot easier to take 3/2 estimate of a number that never ends than to try to even start dividing by a number that never ends into a finite number. Also, if you see that this is a rationalize the denominator, get it? We rationalize the denominator because there's a radical in the denominator, and we remember that I is really a radical. It's really square root of negative 1. So that's why we have to rationalize the denominator by doing a conjugate. Math just makes so much sense. Okay, so the top part is the hardest part. There's no conjugate going on here, so you just have to take your time and do it out. Once again, I do 5 plus 2i times negative 3 minus I. I times 2i is negative 2i squared. Negative I times 5 is negative 5i. Negative 3 times 2i is negative 6i. Negative 3 times 5 is negative 15. Add them together, like terms. And hopefully we can start taking this shortcut right here. We can start recognizing this I squared as negative 1. And in our head, we can go negative 1 times negative 2 is really a positive 2. So that when we go to write this, we realize that negative 15 plus 2 tells me I have negative 13 real parts minus 11i imaginary. Now, careful. Sometimes it's okay to leave this as negative 13 minus 11i over 10. But generally, they want you to write it in a plus bi form. A plus bi form is basically a shortcut for saying we want you to clearly state the real part of our number and clearly state the imaginary part of our number. What does that mean? Well, let me clean up down here. Let's get rid of all this. And they just basically want you to do this. They want you to say, hey, negative 13 over 10, if we do our pretzel, negative 13 over 10 is our real part, and our imaginary part is negative 11i over 10. So you have your choice of writing it as such, or if for whatever reason, you could write it as such also. Both are correct answers. All right. So basically, that's the only thing you really have to know about when doing division, is you must use the conjugate. And the conjugate makes the middle terms drop off because they will become additive inverses of each other. Remember, we only change the middle sign. We don't change the front sign of the first term. So now you need to know these shortcuts down here. So basically, you need to know the difference of when you take a plus b squared, when you're squaring a binomial. Remember, it's square the first, square the last, double this product to complete my task. And then you must recognize a conjugate, a minus b times a plus b, quickly is a squared minus b squared.